Docker looks very simple from the outside, but internally it uses a powerful Docker architecture. So these are the following components of that specific architecture, and each component has its own responsibilities. So this is a typical Docker architecture here. Okay, right from starting from the user who types the commands to the Docker CLI to the Docker daemon. Then there is the container daemon, and then there is the runtime container and the kernel. We will have a look at each component in detail in a very simple language. Okay, so Docker follows a layered architecture here. So it consists of the following components, just as I mentioned in the diagram. So let's get started with the first one. Is a Docker client. So what is a Docker client? So Docker client is nothing but the command line tool which you interact with, where you type your Docker commands. For example, I have a command line tool here in the Windows terminal, so I can just type any Docker command here, like Docker images. This will list all the images of the Docker. So this is the CLI tool wherein I mention what commands I need to type. So this is the CLI tool here. So we can run any commands here. So the client here does. So the client which is here, right? It does not create the containers. It only sends the commands to the Docker daemon, right? So I'm typing the commands in the Docker CLI, and it is sending the commands to the Docker daemon here. Okay, client talks to the daemon using a Unix socket. So we'll move on to the next component, which is nothing but the Docker daemon, right? As the name suggests, it's the most important component of the Docker architecture. So also called as dockerd, it is the Docker daemon, the main brain of the Docker architecture. So this exposes the Docker REST APIs and implement Docker specific features. So whenever we type a command, okay, it exposes a REST API, and all the commands are handled by the REST API. So it handles all the Docker CLI commands. It also takes care of building the images and pull and push of images to the Docker registries, management of the networking of the containers, management of the volumes, supporting the Docker Compose. And let's say you want to authenticate with the Docker Hub or any other Docker registry, that is taken care by the Docker daemon, and high level container management. So it does not create the container on its own, it delegates the responsibility to the next step. Okay, so from the Docker CLI, all the commands are gone to the Docker daemon. So it handles all the image management, volume, and all that stuff. Also handles pushing and pulling from the Docker registry. So we'll come back to the Docker registry later. But yeah, this is what it handles, and anything related to the container management or creation, it is going to delegate the responsibility to the container team, which is the next component. So any command, if you type right, so in the Docker daemons, what exactly it is trying to do is it's going to pass all the flags which is mentioned in the command. It validates the command, sets up any networks or volumes, decides which image to use, and asks the container daemon to create or start the container. So then we move on to the next one, which is nothing but the container daemon. So as the name suggests, right, it's an industry standard container runtime. Okay, it is not Docker specific. The main responsibilities of this container daemon is to manage the container lifecycle. Creation, starting, stopping, deleting, all this thing is taken care by the container daemon. And this is what the container daemon is going to interact with the runtime container. And this is the component which is actually going to create the container for it. Okay, and it is going to handle the low level container task. For example, let's say a Docker daemon says start this container. It is going to delegate the response to the container daemon. So from the Docker daemon, it is going to go to the container daemon right here. Okay, and so why did Docker introduce this container daemon? So before Docker, we had a huge monolithic daemon. It was very difficult to manage, and it was very hard to integrate with the Kubernetes. So the solution was like, the solution was to split those responsibilities. The high level responsibilities will be taken care by the Docker daemon. Any low level responsibilities of container management will be taken care by the container daemon. Now the Kubernetes can directly talk to the container daemon, and but Docker internally still uses the container daemon. So we moved from the Docker daemon to the container daemon, and container daemon delegates the responsibility of creation of containers to the runtime component, runtime container, which is the uh, next component. So also called as runc. This is a low-level container runtime which is used by the Docker to actually create and run the containers on the Linux. So what does this runtime container do exactly? Okay, so this is the one which is actually going to provide the isolation support or the container isolation it is going to do. So actually it uses the Linux namespaces which are provided by the kernel. So this namespaces decide what the process can see, right? So the isolation is provided by the kernel, but it uses the namespaces. So what kind of isolation it provides? It provides the process isolations, also network interfaces, file system mounts, all inter-process communication, host name. So all this isolation, which is required by a container, is provided by this Linux namespaces. Then similarly, we have C groups. Okay, and so this controls how much how much a process can use, or how much CPU memory or IO limits a specific container can use. So this limitation is set by the C groups. The resource control is set by this C groups. Say, for example, if you are running like how much memory you want or how much CPU is required. So all those things are again decided by C groups. But again, it is provided by the kernel. It just uses it. Runtime container just uses this, which uses this facilities which are provided by the kernel. Also, it sets up the container root file system, start the container process, and it talks directly to the Linux kernel. So as I mentioned earlier, right? So this runtime container does not provide the isolation to the container itself. It is just uses the features which are provided by the Linux kernel. So why does the Docker require the runtime container? So before runtime container, Docker had its own runtime. Okay, later Docker donated this runtime to the Open Container Initiative. Okay, so it is runtime container is the OCI reference implementation. So it works with both with Docker and Kubernetes, and it makes the container standardized and portable. As I mentioned, this runtime container directly talks with the Linux kernel, which at the execution layer, right? For example, this is the main Linux is what it is going to provide the process isolation, and it also implements the C groups, which provides a resource control, file system abstraction, networking. All this are provided by the kernel. So container is nothing but the normal Linux process, just which are isolated using the kernel features. So at the end, we have the container, and the app is running as the process ID one inside the container. Any logs which are present are streamed back to the Docker daemon, and the status also is tracked by the container daemon. This is what we have discussed. Okay, initially it builds the Docker daemon actually builds the images, manages the containers, networking, and the volumes. Container daemons manages the container lifecycle. It is the runtime container which actually create and runs the containers with the help of the Linux kernel. Now all the isolation, the resource control is provided by the Linux kernel. So Docker cannot run containers without the runtime containers. So in the diagram which we saw here, right, we had a Docker daemon. It was like it was pulling and pushing the images to the Docker registry. So let's try to understand what is the Docker registry here. So what is a registry? So it's nothing but the storage for the images. For example, Docker Hub, AWS Elastic Container Registry, and GCP Artifact Registry. So this is a hub where all the images are getting stored. So Docker daemon can also pull the images or push the images from the registry. So internally, all the images are transferred layer by layer, and if at all it is existing in your local, those layers are skipped. So this is a Docker hub. Okay, official website of Docker Hub. And if you want to, let's say, pull or push an images from the Docker Hub, you can use this command here, right, which is mentioned here. And all the documentation of the images is mentioned here. And if you want to pull images from there, you can use pull the images using tags also. And yeah, this shows all the details if you want to refer for any images per se. Okay, coming back to here, so this is a complete picture here. So users runs the command. So Docker CLI actually sends that command to the Docker daemon, and it is going to check if it is trying to get some images. It is going to check if the images are already present locally. If it is not present, it is going to send the request to the Docker registry. Okay, and then it is after from the Docker registry, it's going to download all the image layers and verify the checksums and store it locally. So once we have the Docker images, then it is going to send the request to the container daemon here, which is going to do all the image unpacking and the snapshot, and it's going to create the container metadata, and then it's going to delegate the responsibility to the runtime container here, which is going to create the namespaces, apply the C group, set up the root file system with the help of the Linux kernel. So at the end of the day, we have a container process started with the process ID 1, and then we have the running container.